All right, so before we start looking at our main idea for day 4, which is performing linear regression but with technology, I want to just take a moment to kind of go back and review days 1, 2, and 3 within the context of an entire problem. So what we're going to do is we're going to take some real life data and we are going to make a scatter plot of the data. We're going to identify the variables. Then we're going to kind of switch into trend line. We're going to draw the trend line or estimate that location. And we're going to use that trend line to make some predictions. And we're also going to make sure that we're describing the trend line as either increasing or decreasing, because as we saw, that does eventually get us into talking about correlation and if the correlation is positive or negative. We'll also take a look at the strength of the correlation of the data and using it to estimate the correlation coefficient or the R value that we looked at yesterday. And then we're also going to just make sense of the problem. Use the data that we have to help us make informed decisions. So for this, I have a note sheet put together that looks very similar to the type of assignment you're going to be doing in just a few moments. All right, so let's take a look at our situation for our notes today, our example. It says here that Mr. Bannett's family is in the market for a new mid-sized car. He wants to save a little money, so he does some research on used mid-sized cars. His research is shown on the table below. So here's what I found. We have the age of the car is the first variable, so that's like our X variable. I'll just go ahead and label that. Anytime we're dealing with table of values, it's like input output. X is first, Y is second. So we have different ages of cars. So I found through my research that there was a 1-year-old used car, so in other words, a 2020, that was $29,000 in terms of its value. A 3-year-old car was $24,000. A 4-year-old car was $21,000, and so on. You can see the other numbers there. So what we're going to do is we're going to just kind of take a look at our data. We're going to look for a trend in our data, and we're going to see if we can use that to answer some questions down below. All right, let's start with number 1, identify the variables. Now, on the homework assignment a few days ago, a lot of students must have, maybe went to the notes or Google and just typed in dependent variable because they gave me a definition. I don't want a definition here. I want, based on this problem, which variable is the dependent variable. Now, what we did talk about is that the dependent variable is the one that depends on the other variable's value. So in this case, and in any case, the dependent variable is the Y variable. So for this, it is the car's value. So the independent variable, that's the one that always is the X variable, which would be the age of a car. All right, so anytime I ask for dependent and independent variables, I'm not looking for definitions. I want specific to this problem, which variable is dependent, which variable is independent. All right, number 2 tells us to make a scatter plot of the data. Label the axes with the variables and be precise. All right, well, I'm going to start by labeling the axes and then we'll go back and get our data. So I know that X was the age of the car. So I'm going to go down to the X axis and I'm going to go ahead. You know what? I'm going to type because it'll look nicer. Age of car. And I think I can change color here. There we go. Just move that over more towards the middle. And then for my y-axis, we had the car's value. Okay, so I'm going to type in car's value, and I think I can rotate this. There we go. You guys see how I did that? After you type it in, when you're in this text box up here in the text toolbar, the way end, there's a little rotate arrow, and you can rotate that text on your own. All right, so we've got our axes labeled. Next, we need to plot our data. See if we can get my table to show up. There we go. Car's value. So a 1-year-old car was $29,000. So I'm going to change my drawing tool to about a size 6. And I notice that on my graph, my scatter plot, I've got the age of the car, so the 1, 2, 3, 4, 5, those are all labeled down below. And then it looks like I'm going up by 1,000 for every one of these marks: 1,000, 2,000, 3,000, 4,000, 5,000. So what was it again? A 1-year-old car was $29,000 right there. A 3-year-old car was $24,000. I know this 24,000 is just below 25,000, counting by 1,000 for each. A 4-year-old car is $21,000. 21,000 right there. And then I had a 6-year-old car was 18,500. 6-year-old car was 18,500. So I know 18,000 is going to be this line right here. 19,000 would be the next one. So 18,500 is right in between those two values. So I believe that was, again, a 6-year-old car was 18,500. Trying to get right in the middle of that line. There we go. All right, a 7-year-old car was 19,000. So age 7, I go up to $19,000. All right. Age 10 was $9,000. Starting to see the cost really come down once we hit 10 years old for a vehicle. 11-year-old vehicle, $6,000. And 12 years old was $7,000. 12 years old, 7,000. All right, so there's our scatter plot with the different points representing the different amounts of, or the car's value for the different ages of cars. Okay, so I can definitely see a trend here. So step 3 says use the straight edge. Well, I'm just going to use my line drawing tool. So I go to line. I'll just do stroke thickness of 1. That'll be fine. I'll use orange for my line. And draw a trend line for the data. Now, one thing I noticed on previous homeworks, I saw a lot of students just doing a small line segment that only stretched across part of the graph. We want to extend over the whole graph. I can see that my trend is upper left, so somewhere up here, down to the lower right-hand corner. And I want to go all the way across my graph. And I may even need to adjust this a little bit. So if I click on the line or get it to highlight, I can get this little dot to show up at the end. There we go. And I can grab that and move it around. Let's see, my trend line. I want it to be as close to these points as I can get. If I move it any lower, some of these other points up above are going to get further away from the line. So I'm going to say that, you know what, I'm going to bring this side down just a little. A little bit closer. There we go. Now, my trend line might be a little bit different than your line, but it should have that same general angle. We can definitely tell that the line is decreasing from left to right. In other words, as the age of the car increases, as the age goes up, what happens to the car's value? Well, as I go to the right and follow these data points from left to right, I see that the values typically go down, they decrease. The car's value is lower. So in number 4, I'm going to go ahead and type that in. As the age of the car increases, try typing that again. There we go. As the age of the car increases, the value of the car decreases. So I'm comparing the variables there. Age of the car was my independent variable. Value of the car was my dependent variable. And I'm explaining that, what's happening. Are they increasing or decreasing for each one? All right, number 5, is the correlation between the age of a car and its value, so between the two variables, is it positive, negative, or none? So referring to the correlation. Remember from a few days ago, we had different types of correlation. And in this case, anytime that I have this downward trend in my data, that's going to be a negative correlation. All right, next, number 6 is the correlation between the variables, strong or weak. So the strength of the correlation just kind of describes how close these points are to my trend line. Now, if they're scattered and they're a long ways away from the trend line, we say it's weak. If they're pretty close to the trend line, we say it's strong. And in this case, I would think that we actually have some pretty good data here. These points are pretty well matching that line. So we're going to say a strong correlation. All right, last thing here for this part is estimating the correlation coefficient. Now, this is the hard one. This is what I had you guys kind of look at on, well, yesterday, I guess. It was on Tuesday. When we're looking at assigning a value. Okay, this correlation coefficient is a number that's between -1 and +1. Or let me rephrase that. It's between 0 and -1 if it's a negative correlation. It's between 0 and +1 if it's a positive correlation. Well, we know here that we have a negative correlation and we know that it's a strong correlation. So when we look at our scale of how things are kind of laid out with correlation, 0 is kind of like that no correlation, all the way up to 1, as in like 1.0, a perfect 1, is strong correlation. So we want to present a number. Think of this as a number line where this is like in the middle at 0.5, so 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 7, 8, 9, and 1.0. We want to present something that's up on this upper end. Typically for strong correlation, we say it's anything from 0.7 and up. A 1.0 is a perfect correlation, and that's when the points line up perfectly, kind of like with linear equations in last unit. This wasn't a perfect correlation, it was just strong. The more scattered these are, the more we want to make it a number closer to 0. But this is actually a strong correlation. I would just say, something about 0.9 is a good estimate. I do want to also remember that this was a negative correlation. So for my number, my R value, I have to make sure to give it a negative sign because it has to match that same type of number and type of correlation. All right, so let's take a look at some follow-up questions. It asks us to use the scatter plot up above that we created and the trend line that we drew to answer the following questions. All right, number 8, the sweet spot for buying a used car is 5 years because the price has come down and it still doesn't need many repairs. In other words, the new cars are the ones that cost a lot of money, but eventually if you get cars that are 10, 12, 15 years old, yeah, they're going to be cheaper, but you're also going to be paying a lot more in cost of repairs. So that sweet spot is about 5 years old. So how much money could I expect to pay for a 5-year-old car based on the trend? Okay, so what I'm going to do is I'm going to go up to my scatter plot, and I am going to use my line of fit, my trend line, and what I know about graphs. Okay, so the age of the car, I'm going to say a 5-year-old car. That was what I was looking for. So I am starting kind of down here with my eyes. And I'm just going to follow that up. A 5-year-old car, according to my trend line, would be, if I make a dot right there, it appears to be, follow this line over, what does this little line represent? Right above the 20,000. Remember, we counted by $1,000 for each mark, so that would be $21,000 for this one. Okay, a 5-year-old car, I can expect to pay $21,000. I'll say about $21,000. And it does say to add this point to the scatter plot using a different color. I did do that. We put that in green on the scatter plot. All right, so question number 9. Mr. Bannon found a used 13-year-old car. Oh my, that's kind of old. How much money could he expect to pay for this car based on the trend? Well, hopefully it doesn't cost a whole lot because it's 13 years old. But let's use our scatter plot, the trend, to answer this question. How much money could he expect to pay for a 13-year-old car? And it does say to add this point to the scatter plot. All right, drawing tool 6. Let's do this bluish purple color. All right, a 13-year-old car. Zoom in here to make it easier. So a 13-year-old car, if I go up to my trend line, it would be right there, kind of right in between those two grid lines. So now if I follow that over to my y-axis, I'm trying to figure out, well, how much money is that? Okay, I'm following over from the blue dot, which was in between these two lines. Well, I know that that's between $3,000 and $4,000. So, well, let's see, a number that's between $3,000 and $4,000. Well, how about $3,500? About $3,500. It's just an estimate. It's not an exact answer, but it's based on the trend, based on just using my trend line. I'm just making a prediction based on what I see. It's part of what linear regression is all about. All right, so how do we use this? It says if the car above is listed for $10,000, should he buy it? What do you guys think? If my trends tell me that that car is valued at $3,500, should I buy it for $10,000? Of course not. That would be a ripoff. So I'm just going to explain no. And I know this sounds silly to say my own name, but no, Mr. Bannett should not buy the car for $10,000 because its value is about $3,500. I'd be wasting my money if I paid that much more. You know, if I found that same car and it only cost me $3,500, you know, I maybe could if I wanted to not spend a lot of money, but risk buying an older car that might have costly repairs in the near future. All right, next question, number 10. Mr. Bennett decides he is on a budget and wants to spend no more than $12,000 on a used car. Using your trend line, what age of a car could Mr. Bennett expect to buy? Add this point to the scatter plot using a different color. All right. Well, let's go with, yeah, let's do this color, brownish color. All right. Let's see, wants to spend no more than $12,000, and we're supposed to now figure out what age of car could I buy. So I'm kind of working backwards. I'm starting with a value, and I want to use my trend line to figure out what age of a car would have that value. So $12,000 would be, let's see, it's 10,000, 11,000, 12,000. So if I follow that over along this line, and I go all the way to my trend line, it's right about there. Okay. Now, how old of a car could I expect to get? It looks like it's going to be just to the right of the 9. So yes, I could expect to get a 9-year-old vehicle. I would not be able to get a 10-year-old vehicle because, or excuse me, I suppose I could get a 10-year-old vehicle because that's only $10,000. I could not get an 8-year-old vehicle because that's going to cost more. So about 9 years seems to be what my trend line is saying. Nine years old for about $12,000. All right, and our last final question. Gotta put your thinking caps on for this one. So, can Mr. Bandit use linear regression? This process, just like we did, we made a scatter plot, we used a trend line, we were able to look at the trend and make predictions based on the trend lines. So, could I use this to determine exactly how much a used car is going to cost? Exactly how much it's going to cost? No. Could I use it to estimate or predict about how much it's going to cost? Yes, but not exactly. That's not what linear regression does. It gives you an estimate. It doesn't give you an exact value, though. So I'm going to say no, because linear regression can tell me what is expected, not an exact value. All right, so hopefully that kind of helps bring everything together as like a big picture as to why we do what we do, why we've been working with scatter plots and trend lines and talking about correlation. I know there might be some parts that are still a little bit confusing, like this correlation coefficient, but hopefully this helps you understand what linear regression is. It's taking this original data and doing what we did. We did a data analysis using a scatter plot and a trend line to help us make sense about these problems. All right, so I'd like you to do is complete the day 4A homework assignment, which you'll find posted in Schoology. Very similar to this setup, just with different data and a different type of problem. All right, so good luck, and I'll check back with you tomorrow.